Imagine finding a movie script of a conversation with an AI, but the AI's lines are entirely torn away. Suppose you have a machine that does exactly one thing. It calculates the most logical next word. Feed your incomplete script into it over and over, and it slowly generates the missing dialogue, one word at a time. When you interact with a modern chatbot, this step-by-step word prediction is exactly what is happening behind the screen. We rely on these systems for incredibly complex tasks, trusting them to analyze intricate cybersecurity threats or write hundreds of lines of functional software code in seconds. Because they accelerate productivity and output fluent sentences, it is easy to assume there is a conscious mind at work. But these systems do not think, reason, or understand human concepts. A large language model is simply a highly sophisticated mathematical function designed to process massive amounts of text. Understanding these underlying mechanics reveals how the math maintains the appearance of a thinking mind. Instead of predicting one word with certainty, the model assigns a probability score to every possible next word. Selecting lower-ranked words at random makes the output feel natural, which is why answers differ every time. The exact probabilities assigned to those words are determined by parameters. These are hundreds of billions of continuous numerical dials operating behind the scenes. When developers first build a model, no human sets these dials. They begin completely randomized, meaning the untrained system initially outputs total gibberish. To fix this, an algorithm called backpropagation passes trillions of internet text examples through the model. It compares the AI's random guess against the actual text, adjusting those billions of parameters slightly to reward correct answers and penalize wrong ones. That dramatic shift from random noise to fluent language is just the result of tuning these mathematical dials through billions of microscopic corrections. The sheer volume of data required to make those corrections is immense. Reading nonstop, 24 hours a day, it would take a human over 2,600 years to consume GPT-3's training text. Running the necessary mathematical calculations for the largest models on a standard computer would take well over 100 million years. To process that data in a practical timeframe, engineers rely on optimized chips called GPUs, which execute millions of operations simultaneously. This physical infrastructure provides the brute force required to process these trillions of examples, bridging the gap between theory and function. Even with powerful hardware, older AI architectures were severely bottlenecked because they process text one single word at a time. The 2017 transformer architecture changed this by soaking in entire text blocks simultaneously. Each word converts into a number vector, encoding its meaning. The attention mechanism lets words influence each other, updating bank to mean a riverbank based on context. Because human language relies heavily on context to derive meaning, the mathematical attention mechanism allows the AI to accurately map out those complex linguistic relationships. But a model that has only been pre-trained to autocomplete raw internet text does not automatically act like a polite, safe, or helpful assistant. To fix this, chatbots undergo reinforcement learning with human feedback, or RLHF. Human workers evaluate the AI's responses and rank them based on usefulness. Those manual corrections adjust the model's parameters even further, significantly reducing unhelpful answers and aligning the outputs with what users actually want. RLHF bridges the gap, turning an unpredictable predictive engine into a polished tool you can use every day. Because these impressive capabilities are an emergent phenomenon, the result of hundreds of billions of micro-tuned parameters, it is incredibly difficult to determine exactly why the model makes specific choices. Because the model relies on internal attention scores, its performance is directly linked to the signals it receives from the user. When you provide highly specific, detailed prompts, you give the attention mechanism more data points to narrow down the desired relationships. Understanding how attention manages these relationships allows you to structure requests that more effectively guide the model's output. However, because the AI is predicting probabilities instead of retrieving absolute facts from a database, it will occasionally generate false information with complete confidence. It is critical to build rigorous habits around verifying outputs and cross-checking facts, ensuring you do not rely on mathematical hallucinations for serious professional work. The convergence of massive hardware, parallel processing, and human feedback is what transforms simple word predictions into the sophisticated systems we use today. If you want to keep decoding artificial intelligence and other cutting-edge technology, make sure to subscribe to the This Will Surprise You channel. Hit the like button and leave a comment below about what tech topics you want us to cover next. Thanks for watching.